Hi again, everyone. Dr. Tom McNamara here for our course in trigonometry. In this video, we are going to continue our work with the law of sines, and we're going to solve some applied problems. So I took a problem out of our textbook here, and it's about angle of elevation and finding the height of a building. So we're dealing with indirect measurement by modeling with some triangles here. So what we're imagining in this scenario is we got a person looking up to the top of a building. Now when they're standing here, they measure the angle of elevation and see the angle of elevation is 38 degrees. They walk back 440 feet and they see the angle of elevation is 28 degrees. And the question I want to answer is, how high is the building? How tall is the building? So we could imagine maybe there's a highway here or something like that that they can't get across to measure the distance to the building, but they could go back and measure that. They still want to know how high the building is. Okay, so a couple of things. I want to point out that we do know this angle. Okay, these two angles have to be supplementary. They have to add up to 180. So if this angle is 38, then we know this angle is 142. Okay, and then we do know this angle, but I don't think we really need that. Okay, so what I'm going to do is I'm going to find this distance as kind of an intermediate step. And how am I going to find that? Well, I'm going to use the law. Oh, I guess, sorry. I guess it's probably easier to find, scrap it. I do need this angle. If I want to use the law of sines, I need to know the angle it opens up onto. Okay, well, good thing, this is 170, right? These two together total out to 170, so that must be 10 degrees. Okay, so that's a 10-degree angle up there. Nope. 160, 170, yep, I was right, 10-degree angle. Okay. So, using the law of sines, sine of 10 degrees over 440, and let's go ahead and find the side I originally said. I don't know why I second-guessed myself, I've done this enough at times. Okay, so we're finding that length up there. Okay, so we're going to use the law of sines. And the law of sine says that the sine of my 10-degree angle over the length that it opens up onto, over 440, that should be equal to the sine of this angle over the length that it opens up onto. So sine 142 over x. At this point, we should be pretty good at solving these kind of equations when you have an unknown in the denominator. Kind of what they might call cross multiply. Okay, bring the x up here, bring the 440 over here, divide out the sine 10. You get x equal 440 times sine 142 over sine 10 degrees. Crunch the numbers on our calculator. So 440 times 142 sine equals, divide by 10 sine equals. All right, so I am getting 1560. Okay, approximately. So that tells me this hypotenuse right here. The length is 1560. Now, what I really want is the opposite side. Okay, so now I'm going to kind of fall back to right triangle trigonometry. When I was applying the law of sines, I was working with this triangle, which is an obtuse triangle. This one here does not have a 90-degree angle. Now, I am working with a right triangle. I know the hypotenuse. I want the opposite side. Okay, so thus, sine 28 degrees would be opposite over hypotenuse, h over 1560. And that would imply that h equals, well, you multiply it over, 1560 times sine 28 degrees. We'll go ahead and crunch the numbers here. 1560 times 28 sine equals, and I'm getting 732. Okay, so the height of the building is approximately 732 feet. So we applied the law of sines to get this hypotenuse. And then, once we had that, we went back to right triangle trigonometry to get the height of the building. Okay. We could have also found this length and then worked with this smaller right triangle. It's another way to solve the problem. You'd get the same answer.